Hello everyone, welcome back to Unfog with Dr. Athar Parveen. In one of our previous lectures, we solved a physics question paper of Karnataka TET 2021, paper 2. Their questions were started from 121 up till 128. Question number 128, there were physics questions. Now in this lecture, I am going to solve a chemistry questions part, question number 129 to 135. And the biology part we will solve in the next lecture. That will be from question number 136 to question number 143. So the conclusion is that in physics we have 9 questions. Means 9 questions were asked in Karnataka TET 2021 in paper 2. Okay, 9 questions in physics. Then 7 questions from chemistry and 8 questions from biology. So total 8 3s are 24. 24 questions were asked from science. Okay, even maths question paper I have solved, this Karnataka TET 2021 question paper. You will find it in this YouTube channel only. And physics question paper also I have solved. Actually question paper is same. In that same question paper we have mathematics, physics, chemistry and biology. Physics, chemistry and biology come under science, isn't it? So maths part I have solved separately, physics part I have solved separately. Today in this lecture I will solve chemistry, and for biology we will take another lecture. Okay, and we will just not solve the questions, we will also try to analyze the question paper and try to see some questions based on those questions. If you have seen my physics lecture which I have solved from this previous year Karnataka 2021 question paper, if you have seen that video, then you will understand my teaching method. What I actually do is, first I solve that question, then I say from which chapter that question has been come, and I also give few ideas and few questions based on that question. Okay, that thing we will do it in this lecture also. So let us start. Question number 129. See, this is paper 2 question paper, friends. Paper 2 of Karnataka TET 2021. Question number 129 is starting question for chemistry part. The question is, this artificial sweetener has maximum sweetness compared to other sweeteners: saccharin, aspartame, allitame, sucralose. See, this question is asked from the chapter Chemistry in Everyday Life. There are many names for this chapter actually. Chemistry in Everyday Life or Chemistry in Our Daily Life. Basically, the applications of chemicals is been taught in this chapter. I have made lectures in GPSTR time based on this chapter. Now again I will make it for you people, Karnataka TET aspirants also. Okay. First I am solving the question paper because we will get one idea, right? After getting that idea, we can go through the chapters and try to understand what type of questions will come from that particular chapter. Okay. So the answer to this question is allitame. Allitame. Another type of question can be asked this time. The question could be, the artificial sweetener which is a derivative of sucrose is. The artificial sweetener which is a derivative of sucrose is sucralose. Sucralose, it is made from sucrose itself. It is a derivative of sucrose. Another question could be like this also. Artificial sweetener which is stable under cold conditions only. Means among the 4 given options, saccharin, sucralose, aspartame and allitame, there is one artificial sweetener which is stable just under cold conditions. If the temperature is raised or if the conditions are of heat, then it will not be stable. It will become unstable. What is that artificial sweetener? Actually that is aspartame. So aspartame, it is stable only at cold conditions, but it will become unstable at higher temperatures or cooking temperatures. It is 100 times sweeter than the cane sugar. Even this can be asked as MCQ. How many times sweeter it is than normal cane sugar which we use, the white sugar which we use in our kitchen? It is 100 times sweeter than the cane sugar. Now, because this aspartame, it is stable only at cold conditions. That's why it is used only in cold foods. Means the sweets which are made without cooking, maybe some juices, maybe sharbat and all, you can use it there. Means the foods which can be used only as cold foods, means which can be served as cold foods, their cooking should not be required. In such foods, this chemical or artificial sweetener aspartame is used. Okay. So these are the questions I guessed from my side. Any type of question may be asked. So see, just with this question, we guessed 2 questions here plus another question also. It is 100 times sweeter than cane sugar. Aspartame is 100 times sweeter than cane sugar. That is one more point we gathered now, isn't it? Now they can ask another point also from this information. As MCQ they can ask. They can ask that which artificial sweetener is used only in cold foods. They will give the same 4 options. Then you should know that it is aspartame because it is stable only under cold conditions. Okay. Now aspartame is 100 times sweeter than cane sugar, but it is not the chemical or it is not the artificial sweetener which is maximum sweet, which is having maximum sweetness. The maximum sweetness is allitame. Okay. Here in question number 129, option 3, allitame is the right answer. Okay. So this question was from chemistry in everyday life. So the moral of this story was that we should read this chapter very carefully because question can be asked. Every exam they ask one question, at least minimum they ask from chemistry in everyday life. Out of my experience I am telling. So we cannot neglect this chapter. Okay. Next, question number 130. Lambda is equals to h upon mv is equal to h upon p. This famous relation is given by Erwin Schrödinger, Werner Heisenberg, Louis de Broglie or Alfred Warner. 4 options are given. First of all, here in this type of situation, you first have to recognize the formula because they have not given what is lambda, what is h, what is p, what is m, what is v. We don't know anything, right? But if we know this relation, then we will know the answer for this question also. Now this chapter, structure of atom in chemistry, is having all these stories about Schrödinger, Heisenberg, Warner, de Broglie and many more. Bohr is there, then Dalton is there, Thomson, J.J. Thomson is there. All the stories they have constituted in this chapter of structure of atom. So that chapter is very easy chapter. It contains sort of history of modern physics, you can say. Okay, so this question is from physics actually, but then part of physics is there in chemistry also, right? So this is a chemistry part question now. Now the answer to this question is Louis de Broglie. Actually Louis de Broglie, he was the one who explained the wave nature of light and wave nature of matter. Basically it is dual nature of matter and dual nature of light. He told that the wavelength of the wave, which is lambda here, is equal to h upon mv, where h, it will be the Planck's constant and its value is 6.63 into 10 raised to minus 34 joule second. It is a constant, right? It is a constant given by Planck. That's why its value is same always. Okay. Lambda, I told you, right? It is a wavelength and its unit will be in meter and usually it is known as de Broglie wavelength. And m is the mass of the particle. Its unit will be in kg. Velocity will be the v. The velocity of the particle will be v here, which is meter per second. And this p, no, this p is equal to m into v, mass into velocity. This p is momentum of a particle. See, we are talking about a particle, then we are telling about the wavelength of that particle. Why we are saying like that? Because de Broglie told that particle can move in a wave also, in the manner of a wave also. It can travel like a wave also. That is dual nature of matter, given by Louis de Broglie. He is the one who proposed it. Okay. So this was all about the formula. Now what about the rest of the scientists here? What they have done? First though I told you about de Broglie, wave particle duality. The wave associated with particles in motion, it is called matter waves. And de Broglie, he proposed that not only light moves like a wave and a particle, but also particles also move like waves. Now that particles could be electrons. Okay, small particles, the microscopic particles, they appear to move like a wave, but then even we are also moving like a wave, but no one can see us because the wavelength is so small that no one can see us. That wavelength is inversely proportional to mass, right? Whenever the mass increases, the wavelength will decrease. We are huge particles, right? That's why no one can notice. Now the wavelength of this material waves, it is also known as de Broglie wavelength. This was all about de Broglie, right? Louis de Broglie. Next comes Erwin Schrödinger. He took this idea of wave particle duality given by de Broglie. Assuming this wave particle duality, Erwin Schrödinger, he formulated one equation for this wave. De Broglie told that particles are moving like a wave, right? But then that wave should have one equation, right? That equation was given by Erwin Schrödinger in 1926. Actually, he was the one who accurately calculated the energy levels of electrons in atoms. With that, he gave that wave equation. So this was about Erwin Schrödinger. Now what did Werner Heisenberg do? He discovered the uncertainty principle. What is uncertainty principle? The uncertainty principle, it states that both the physical quantities, position and momentum of one object, you cannot know them at a time exactly. Means you cannot catch them at a time, you can say. If you know the position, then you will be having some uncertainty in momentum. Uncertainty means not sure. You are not sure of the value of momentum. At the time when you note down the position, you cannot note down the value of momentum. At the time you note down the value of momentum, you cannot note down the value of position. At that particular time, you can't do it. It is uncertain, right? That's why this principle is known as principle of uncertainty. It is given by Werner Heisenberg. Basically, here also example, you have to take electron only. Electrons are the examples here for this wave equation also and for uncertainty principle also. Next comes Alfred Werner. What did he do? Basically, he is a chemistry person. He proposed octahedral configuration of transition metal complexes. He is also known as the father of modern inorganic chemistry. This can be asked as a MCQ. Father of modern inorganic chemistry. Who is he? Alfred Werner. All these people were Nobel Prize laureates actually. Even he, Alfred Werner, was given Nobel Prize in 1913 itself. But all these people, they all have been given Nobel Prize. Years I have not mentioned here, but then I don't think they will ask year. Okay. If you are interested, I will give you the list if you want. You just let me know in the comment section. Okay. So this was about structure of atom. Actually, they can ask many more questions from this chapter that we will discuss while discussing this chapter particularly. I will make one video for one chapter. Okay. Next, question number 131. Electronic theory of chemical bonding was developed by chemical bonding. This question should be from chapter Basics of Chemical Bonding. Now, who developed this electronic theory? It was developed by two people, Kossel and Levy. These two people together, they developed this electronic theory. They can ask another question like this also. The theory developed by Kossel and Levy are called, it is called electronic theory of valence. Actually, this Levy theory, it revolves around valence electrons. What is the role of valence electrons in chemical bonding? We all know that valence electrons, they are the heroes of chemical bonding because they are the only one because of which there is bonding between two atoms. The bonding between two atoms is possible only because of these valence electrons. Now, what are these valence electrons? They are the electrons that are present in the outermost shell of an atom. In atom, electrons are revolving around the nucleus, right? They are revolving in shells. In that, the outermost shell also will have few electrons. If you write the electronic configuration, you will come to know. You distribute the electrons, right? Once you write the electronic configuration, the outermost shell contains few electrons. Those electrons are known as valence electrons. Now, how do these valence electron play the role in bonding? Actually, what happens is the valence electrons of one atom, they bond with the valence electrons of another atom. That is how bonding happens. Basically, for an element, bonding happens by filling their octets. Octets means electronic configuration. That also I will teach you in this chapter. When I take down this basics of chemical bonding, then I will teach you how to write the electronic configuration and all that. Basically, octets means that element, it will achieve noble gas electronic configuration. It is known as octets. Now there are two ways by which electrons are used to form bonding between two atoms. First way is ionic bonding. Second way is covalent bonding. In ionic bonding, there will be complete transfer of electrons from one atom to another. And in covalent bonding, there will be sharing of electrons between two atoms. Means electrons will not leave their atom. Staying in that atom only, they will bond with other electrons from other atom. Okay. So the answer to this question is electronic theory of valence. This was developed by Kossel and Levy. Okay. Now in chemical bonding, they can ask many more questions like this. For example, what Kossel-Levy approach of formation of chemical bond follow? Of course, it follows octet rule. Just now we told, right? This octet rule, it will state that elements gain or lose electrons to attain one electronic configuration. What is that electronic configuration? That should be for a nearest to noble gas electronic configuration. Now these noble gases, they have complete outer electron shells. Means they are very stable. The noble gases, they are very stable because their outer electron shells are completely satisfied. They are completely filled. They don't need any other electrons to be bonded. Okay, that's why they are noble gases. They are the most stable gases. Other elements are not like that. In the periodic table, they seek some stability. This will govern their reactivity and bonding behavior. Because if the electrons in the outermost shell, if they are not completely filled, then they are unsatisfied. They need electrons from other atoms. That's why bonding and reactivity takes place. Okay, but all this happens only with the octet rule. This was given by Kossel-Levy approach. This Kossel-Levy approach of formation of chemical bond, they followed this octet rule. Now from this chapter, many more questions can be asked. A few questions I have guessed and I have put it here. But we will discuss more and more questions when we discuss this chapter particularly. Now these questions, they are very common questions, you say. Means I am expecting one question from this in this year in Karnataka TET, okay. Who was the first to propose atomic theory? It was John Dalton. The first model of an atom was given by J.J. Thomson. So I have a table here like this. J.J. Thomson, he also gave electron discovery. Actually, electron was discovered by J.J. Thomson. Then Rutherford, he discovered alpha and beta particles. And this John Dalton, he first proposed atomic theory. That's why he is also known as father of atomic theory. Okay. See here, with this only 1, 2, 3, 4, 5 questions can be framed with this information only. So you please note down, you make notes or you make list and you just to go through all the scientist names and their discoveries. Next, question number 132. Milk is an example for. Actually, it is from this chapter, surface chemistry emulsions. So answer should be emulsion for this. But why, that I will tell you now. See, there are some few types of materials are there. They are known as colloidal solutions. Okay. Now that colloidal solution, it is mixed with a liquid and a gas. If that colloidal solution is mixed with liquid and a gas, it is known as aerosol. Okay. Now another type of material is there which is known as emulsion. In this, no, one liquid is dispersed in another liquid. In aerosol, liquid and gas were together, right? They were mixed together. In emulsion, one liquid is dispersed with other liquid. But one liquid is known as dispersed phase and other liquid is known as continuous phase. Example for this is milk. In milk, what all are involved together? The milk particles and water, right? That only. Emulsion with fat particles, globules dispersed in aqueous watery environment. That's why milk is a emulsion. Some more information I'll give with some few examples. Another type of material is known as sol. This is also a colloid, but here particles are, means the dispersed phase are solids and they are mixed with the fluid. Dispersion medium is fluid here. Okay, that type of materials are known as sol. If the dispersion medium is water, then colloid is called as hydrosol. Hydrosol. Okay, and if the dispersion medium is air, then that colloid is called as aerosol. I told you, right? The liquid and gas is mixed together. It is called aerosol. Now sols, no, they are quite stable. Always they are stable and they show Tyndall effect. Now what is Tyndall effect? Tyndall effect is nothing but scattering of light from colloid. If light falls on the colloid, then the light will get scattered. It is known as Tyndall effect. Okay. See, I have given you so much of information. They can give you any type of MCQs from this information. Now another type of colloid is a blood. Actually, it is a colloidal solution. Not only blood, starch and ink are also other examples of colloidal solutions. Why they are called colloidal solutions? Because in these solutions, no, the solute particles, they are not visible to naked eyes. Can you see the particles from the blood if you see? No, you can't see it, right? But when they are kept in the dark, they show Tyndall effect. So all the solutions which show this Tyndall effect, they are called colloids. Okay, so blood is a colloid. Next question. Polyester among the following is. From the question only I can say that it is a polymer. The chapter name is polymers. Now polyester among the following is PET, neoprene, Buna N, nylon 66. Actually neoprene is a polyester. Any polymer which is having ENE at last, no, it is a polyester. Remember, this is a trick I am giving you. Neoprene, last letters are ENE, right? So any polymer which is having ENE at the last, they are all polyesters. Okay. Questions like this can be asked. For example, neoprene is polyester, polyamide, polysaccharide, polyhalodene. Neoprene is a polyester. Okay. Next question could be like this. Which one of the following is a polyester fiber? Here I have terylene, ENE is in tellurine. Actually in polystyrene also it is there, but it is not a polyester because already poly is there. No, that type of materials are not polyesters. Poly will not be there. Only ENE at the last should be there and it should be a simple word like this. Terylene, neoprene, like this. So this will be a polyester. This polyestyrene is little bit confusing. You have to remove this word from your mind. It is not a polyester. Next question could be like this. What is not true about polymers? Polymers do not carry charge. Polymers have high viscosity. Polymers scatter light. Polymers have low molecular weight. Actually, polymers, they have very high molecular weight because they contain large number of repeating structural units. If you see the chemical units, then you will understand the chemical structure. Then you will understand they have very high molecular weight because the units in that, no, they have very large number of them and they are repeating. That's why polymers, they are called macromolecules. They are not called micromolecules. They are called macromolecules. The range of the molecular mass will be 10 to the power 3 to 10 to the power 7 units. Okay, 10 to the power 3 to 10 to the power 7 units. We are not even giving the units here because they are macromolecules, right? They will have very high units. Okay. So which is not true? They are telling not true, means which is false statement among these. This should be the false statement because polymers, they have high molecular weight. Okay, option D should be the right answer. Next question, question number 134. A number of elements are available in the Earth's crust, but most abundant metallic elements are. This chapter is occurrence of metals. Actually, metals and non-metals also you can say, because that is also there in your syllabus, right? So number of elements, there are actually so many number of elements are available in the Earth's crust, we know that. But what are the elements which are most abundant, means much quantity is there and they are metallic? What are they? They are aluminium and iron, Al and Fe, aluminium and iron. And what are the other things which are present in the Earth's crust? Oxygen, it is 46.6%. It is most abundant element in Earth's crust. Now in this question they are particularly asking metal, right? Metallic element. That's why aluminium and iron is the right answer. But if you want to talk about any element which is present in the Earth's crust, the most abundant element, that is oxygen. And second most abundant element present in the Earth's crust is silicon. It is 27.7%. And third most abundant element in the Earth crust is aluminium. It is 8.1%. But in this oxygen, silicon, they are not metals, right? Aluminium is a metal. That's why that only we are giving the top priority for this question. Next is iron, 5%. So in these four materials, aluminium and iron are only metals, right? So they are only most abundant metals in Earth's crust. Another question they could ask is like this. Which of the following metal is protected by a layer of its own oxide? There is one metal which is protected by its own layer, and that layer is made by its own oxide. See, here for sure iron is the wrong answer. Why? Because iron, it corrodes, right? It corrodes means it is spoiled, it is not protected. If you throw that iron rod or iron box outside your home, after a few days in rain and because of air and all that, it will get corrode. It will become, in Hindi what they say, zang lagna they say, right? In Hindi they say zang lagna. In Kannada I don't know what they say, but that happens, right? Means it is spoiled. That iron rod or iron box, it is spoiled. That means it is not protected, right? So iron is the wrong answer for sure. Now the right answer will be aluminium. Actually, aluminium, it is reactive and it will react spontaneously with water or air to form aluminium oxide. But it forms a stable passive layer which protects aluminium from corrosion or further oxidation. Okay. Means for us, the zang lagna in iron is a bad thing, right? Means that iron material, it got spoiled. But for aluminium, it is not like that, it seems. It will make one layer which is a passive layer, means it is a good layer. It will only protect that aluminium. Okay, that aluminium oxide will protect that aluminium by making that layer. It will protect it from further corrosion and further oxidation. Okay, so the right answer will be aluminium. Next question, monomers of dacron are. This is also from polymers. They have given 4 options. Actually, monomeric units, no, they are involved in the production of dacron. What are they? They are ethylene glycol and terephthalic acid. Means option 2 will be the right answer. Ethylene glycol and terephthalic acid. Now, what is dacron? Dacron, it is a copolymer. It is prepared by condensation of methyl ester of terephthalic acid and ethylene glycol. The monomer of dacron, what are they? They are terephthalic acid with ethylene glycol. Now this dacron, it is used in blending of cotton in clothing. It is the condensation product of ethylene glycol and terephthalic acid polymerization. This polymerization, it is carried out at 420 to 460 Kelvin in the presence of zinc acetate and antimony trioxide. Okay. So these are the details which I am giving you about dacron. When we discuss this chapter polymers in one separate video, then we can go in more details regarding polymers, because we have seen 2 questions from polymers, right? So we will have to give more priority to this chapter. Okay friends, this was your chemistry part of Karnataka TET 2021 question paper. I really hope that this lecture helps you. Please do sit and watch this lecture, and not only this lecture, all other lectures which I am making based on Karnataka TET. Try to make notes and try to make the list and try to read them out daily. Okay. Now before finishing the lecture, I have a small announcement. Actually, these are the reference books given in the syllabus, right, by Karnataka government. In this list, no, I got one very important book, R.D. Sharma of Mathematics, Class 9 and Class 10. Okay, I have got the soft copies of these two books. I will put it in the Telegram channel. If you have not joined the Telegram channel, please do join the Telegram channel, because I keep sharing data and material there in the Telegram channel, and also I keep you all updated. We also have one discussion group. You can talk to me over that group also. If you have any queries also, you can write to me in the Telegram channel. Okay. Okay friends, then all the best. Keep preparing, because hard work will always be fruitful. Okay. Okay then. Thanks for watching. Bye.